In today's rapidly evolving digital space, smart ecosystems such as smart homes, smart offices, and smart cities cannot rely on conventional authentication systems due to their inherent drawbacks. This tutorial presents Step and Turn, a user authentication solution for smart homes and offices to secure access. This research work is a part of my Ph.D. dissertation titled, Next Generation User Authentication Schemes for IoT Application. Also, we published in a paper titled, Smart Handle, a novel behavioral biometric-based authentication scheme for smart lock systems. Step and Turn is a novel bimodal behavioral biometric-based transparent user authentication scheme. It exploits users' single footstep and hand movement action while they about to enter and turn a door handle to access a secure place. This enables users not to remember PIN or password or carry some token. At the same time, they cannot be shared or transferred to an unauthorized person. In the slide, you can observe the setup. We will talk about sensors in the coming slides. In this slide, related work are presented. Smart Handle utilized the user's hand movement to secure door access. They validated their solution for a multi-class classification scenario, and achieved a true acceptance rate of 87.27% at the false acceptance rate of 1.39% on a dataset of 11 users. SnapAuth exploited users' hand movement to authenticate them on smartwatches, while they perform finger snapping action. They achieved the true acceptance rate of 82.34% on a dataset of 11 users. And HMOG that utilized hand movement, orientation, and grasp behavior reported EER of 7.16% and 10.05% for walking and sitting posture, respectively. Rodriguez performed footstep biometric assessment on their collected 9,990 stride signals from 127 persons by using floor-based sensors. They achieved the equal error rates of 15.2%, 13.4%, and 7.9% by training the classification model with 40, 100, and 500 single footstep signals respectively. Edwards extracted geometric and wavelet features from the footstep dataset collected by the Swansea University Speech and Image Research Group. They achieved an EER of 16.3%. Joe used fabric sensor to record users' footstep and achieved an average identification accuracy of 76.9% on a dataset containing 529 footsteps collected from 13 participants. We created a smart office setup by fixing the hardware to the door handle, as depicted in the slide, in our lab. 40 volunteers participated in the experiment and we collected 40 samples per person. We used Adafruit board that has inbuilt accelerometer, magnetometer, and gyroscope sensors. To acquire X, Y, and Z data stream from these three sensors at the rate of 9,600 bits per second. For the hand movement action for opening the handle. And, we created a chimerical dataset by combining footstep data of 40 participants collected by the Swansea University. They collected the left and right pressure amplitude having 2,200 samples by using 88 piezoelectric pressure sensors at the rate of 1.6 kHz. For hand movements, we extracted 73 features that include handle movement action time and 72 statistical features. To collect hand movements features, we used 3 inbuilt sensors that are accelerometer, magnetometer, and gyroscope sensor. From each of these sensors, we get 3 raw streams X, Y and Z to determine user identification signature generated in 3-dimensional space while they turn door handle downward with their hand. 4th stream magnitude, we derived mathematically using the formula as shown in the slide. Afterward, we computed 6 statistical features from these raw data streams, which are min, max, mean, standard deviation, skewness, and kurtosis. We get 24 features per sensor. As there are 3 sensors, so in total we extracted 72 statistical features. We extracted 224 features from left and right footstep pressure data, in which 48 statistical features are extracted from 2,200 pressure amplitude values acquired from 88 pressure sensors. They are: spatial average, ground reaction force, upper and lower contours, and extracted 6 statistical features which are min, max, mean, standard deviation, skewness, and kurtosis, from each time series array. Afterward, we extracted 176 ground reaction force per sensor for left and right footstep using formulae shown in the slide. We used feature-level fusion. After combing both features' hand movements and single footstep features, we get a total of 297 features. For feature selection, the relief-based selection method provided by the MATLAB tool. We selected the top 33% that we determine empirically. And using these selected 98 features we designed the classification model. You will see the details of the classification model in the next slide. We designed a multi-class classification model for a dataset of 40 users. We utilized the MATLAB PR Tools toolbox and used random forest, stat support vector classifier, and Fisher's square linear discriminant. In the slide, you can observe a random forest classifier gives the best true acceptance rate of 97.25% for the false acceptance rate of 0.01%. With 30 training samples with the selected 98 features per user. In the next slide, you will learn about usability validation performed for step and turn system. For usability analysis, we conducted the SUS survey. System Usability Scale is a standard tool widely used to record user impressions about the usability of a system. A mean SUS score of 68 or higher is considered better with a higher probability of wide user acceptance. For step and turn, we got a score of 76.7. If you have any questions regarding step and turn, please write the comment. Thank you for watching the video. Please subscribe to my channel and like the video.